Alright, welcome to the very first video lesson for the school year 2012-2013 pre-calculus. As you can see, we're going to skip over section 1.1, then come back to that. I'm going to start out with a very easy topic, linear equations, something that you learned in Algebra 1. Now it's a video, so you can pause it, you can rewind if you didn't get anything, rewind so you can get all the notes if I'm going too fast. And if it's review and you feel, hey, I know this, you can fast forward it. Beauty of it is you can go at your own pace. Okay, if you follow the notes, okay, you should have the handout in front of you right now for the notes on 1.2. The first question, what is the slope-intercept form? Well, that's easy. It's our good old y equals mx plus b. Yes, this never goes away. So m, remember we say that's the slope. And a lot of times we say that's rise over run. B, this is where we usually want to begin our graph. That's why we say it's B. That's our y-intercept. So it's the point on the line that hits the y-axis. Okay, let's skip number 2, and we're going to go to number 3. Reason why I'm skipping number 2, that's already in slope-intercept form, so that should be real easy for you to graph. Number 3 is not in slope-intercept form. You have the 2x plus 3y equals 9. This is in standard form. Okay, whenever graphing any lines, if you have an equation, you always want it in slope-intercept form, because once you have it in slope-intercept form, it's very easy to graph. Okay, so I want to get y by itself to get it in slope-intercept form, so I'm going to subtract 2x from both sides. So when I do that, I'm going to have 3y equals negative 2x plus 9. I write the x first because I want the slope first. Then I divide everything by 3, and I'm going to have y by itself. So I have y equals negative 2/3 x, and then 9 divided by 3 is 3. Now it's in slope-intercept form. So this negative 2/3, that's the slope. The 3, that's b, the y-intercept. And that's all I need. Now I'm going to do this by hand, so it might get a little ugly doing it by hand, but yours should look a lot neater than my line's going to be because you're doing it on the grids that are all evenly spaced in front of you right now. Okay, I always begin with the b. So I'm going to go on the y-axis, go up 3 from the origin. There's my first point. And then all I need, the least amount of points I need is 2 points to make a line. So then I use my slope, negative 2/3. So rise over run, that means I go down 2 to the right 3. So from this first point right here, I'm going to go down 2 to the right 3, and here is my second point. And that's all we need. I connect it, and I have my line. See, I told you it was going to be a little ugly. You'll see me putting problems on the board in the videos, and I'm not the best. I'm not the best artist here. All right, so that was number 3. Then 4 and 5 are the special cases. Now, if you take a look at 4 and 5, the one thing that's common is there's only one variable for each equation. If there's only one variable, then that means it's either horizontal or a vertical line. Now, the first one, number 4, has x equals 4. Common mistake, students will look at this and say, oh, well, it's x, so it has to be horizontal because the x-axis is horizontal. But it actually is the opposite. Here's an easy way to remember. Some of you guys might have learned this in Algebra 2. Some of you haven't. It might be new. But this is a good acronym to use. We use VUX. Okay, now what does that stand for? Well, V stands for you're going to graph a vertical line. U stands for the slope of any vertical line, which is undefined. And that's what it's asking us. It's asking us for the slope. So the answer for this is going to be undefined. And then X, this is the only, when you only have one variable in the equation, this is it. So it's X. So that's kind of an easy way to remember there. So if you only have X, it's going to be a vertical line and it's going to be undefined. If you did graph it, you would go to your x-axis, you would go to 4. Okay, I'll do this in a different color so you can see the difference. And you plot this point, x equals 4, and it's a vertical line. Alright, and our answer for this, any vertical line, here's another easy way to remember, you can't walk a vertical line. Gravity would bring you down, so it's undefined. So that's your slope. Okay, the next one, we're going to get a horizontal then. Okay, the horizontal for this equation, we have y equals 2. Now the acronym we can use for this is HOI. Okay, the H obviously is going to stand for horizontal line. And then the O is really going to represent 0. So just think of it as a number. This is just 0. So this is the slope. This is going to be our answer for this one. I'll even circle it. Here's our answer. And then the Y, well, that's the only variable that's present in the equation. All right, so that's an easy way to remember. Hoivux, if you only have one variable present, it's either horizontal or vertical. Here's my y-axis, so I go up to 2. Again, I'll put this in red. That's where y equals 2, and every point on this horizontal line, y is equal to 2. You can walk, this is a flat surface, so you're not going up or down, so your slope is 0. Alright, the next one, again, this should be review. What's the formula for finding slope, given the 2 points on a line? We could say that, we go back to this, x sub 1, y sub 1, and x sub 2, y sub 2. These represent any 2 points on the line. Our formula for slope, remember it's change in y over change in x, or rise over run. We say it's y sub 2 minus y sub 1. Then I have to keep it consistent, so it's got to be x sub 2 minus x sub 1. I could reverse the order, and I could say the top could be y sub 1 minus y sub 2. But if I do that, if I start with y sub 1, then that means I have to start with x sub 1 in the bottom. So then the bottom is x sub 1 minus x sub 2. Either one will give you the slope. And again, that should be review. Okay, and then we're going to do 7. We're not going to do number 8 because it's really the same type of problem. Okay, 7, we want to find the slope of the line passing through 1, 2, and negative 3, 4. So I'm just going to use the slope formula. I look at my y values. I have 2 and I have 4. Well, I can do any order. Let's start with the bigger one. I always like starting with the bigger one because when I subtract, I'll get a positive one. So I get 4 minus 2. Now, if I start with this 4, this means I have to start with negative 3 in the bottom. So it's negative 3 minus the other x value, which is here, which is 1. Then we get 2 over negative 3 minus 1 is negative 4. Always reduce the fractions to the lowest terms, and this reduces to negative 1/2. That's our slope. Okay, once you're done this video, do number 8 also on your own, along with number 2, since we didn't do that in the video. Number 9, point slope form. Here's point slope form. So we'll put here number 9. This is y minus y sub 1 equals m times x minus x sub 1. Now m obviously is the slope. Now this y sub 1 and x sub 1, that corresponds to any point on the line. And here's the difference between this and slope-intercept form. When you do slope-intercept form, you need to get the slope and you have to get the y-intercept. But the good thing about this is you need to get a point. It can be any point on the line. It doesn't have to be the y-intercept. So if they were to give us the y-intercept, I would put it right in that slope-intercept form. But if not, we're probably going to use this form. All right, let's go to the back. Flip to the back of the worksheet. Let's see here. Let's do number 10. All right, number 10, we want to put it in slope-intercept form if the line passes through negative 3, negative 2, and it also goes through the point 1, 6. Now, it says it wants it in slope-intercept form, which we know is y equals mx plus b. So I need to find just two things, slope and m, which is the y-intercept. So I can first use the slope formula to get m. Okay, my y values are negative 2 and 6. I'm going to start with the bigger number, 6. That's what I like doing. Don't always have to do that. I'm going to do 6 minus, and then the other y value of negative 2. If I start with that 6, then I have to start with this 1. So then it's 1 minus this x value here of negative 3. Now if I'm subtracting negatives, these change to positives. So I get 6 plus 2 is 8, 1 plus 3 is 4, 8 over 4 is 2. That's my slope. Alright, so I have m. I need to find b. Now if I look, the points that I'm given, they're not the y-intercept because the x value has to be 0 in order for you to have the y-intercept. This is where I could use point slope form. Now I could use any of the points. I'm going to use 1, 6 as x sub 1, y sub 1, just because they're positives. I think it's going to be easier working with the positives. So if I put this in point slope form, I'm going to have y minus that y sub 1, which in this case is 6, equals the slope, which is 2, times the quantity of x minus x sub 1, which is the 1. Then I just have to get y by itself. I can distribute the 2. I get 2x minus 2. Then to get y by itself, I just add 6 to each side. And now I have it in slope-intercept form. I have y equals 2x. And then negative 2 plus 6 is plus 4. So we wound up finding that 2 is the slope and 4 is the y-intercept. Okay. Next ones 11 and 12, we're really going to have to deal with the slope, and they'll enable us to do 13. Perpendicular lines. Now perpendicular lines, I kind of drew two perpendicular lines here. These are two lines that intersect at a 90-degree angle. The connection between their slopes is that they have to be the opposite reciprocal of each other. So I'll write this out, opposite reciprocal. And to give you an example, let's say I have slope, I'm going to say m sub 1, meaning the slope of line 1. Let's say I say that's 1/2. If I want to graph a line that's perpendicular to it, well, this slope has to be the opposite reciprocal of this 1/2. So reciprocal means I just flip the numbers. So I have it as 2 over 1. And then the other key part says opposite. So since this is positive 1/2, this becomes negative 2, or negative 2 over 1. Okay, for for parallel lines, it's much easier. If two lines are parallel, we know when we graph them they never touch. The connection here is, if you have two parallel lines, you'll see their slopes are the same. So there's really no thinking going on. You don't have to flip anything or take the opposite. It's just the same slope. Alright, the last one, 13. We're going to use what we just did there for 11 and 12. I'm going to skip A, the parallel part, because that's the easier one when you keep it the same. I'm just going to do perpendicular. Now for this last one, when we do 13B, let's see here, it gives us, we want to find the equation of the line that passes through 3, 6, and it's perpendicular to the line 2x plus 3y equals 7. Now, whenever doing anything with parallel or perpendicular lines, the main thing is the slope. Okay, so now here's the thing. I have a point of a line. I probably can put this in point slope form because 3, 6 is not a y-intercept. The only thing I have to find is the slope. Well, if it's perpendicular to this 2x plus 3y equals 7, I need to find the slope for that line. But I need to get this in slope-intercept form to figure out what the slope is. So I want to get this y by itself. So I'm going to subtract 2x from both sides. So I'm going to have 3y equals negative 2x plus 7. And then I divide everything both sides by 3. So the line that is perpendicular to that equation is y equals negative 2/3 x plus 7/3. Now that 7/3 I don't even care about. I only care about this, the slope. So if this is the slope for a line, if I want to find the slope for a line that's perpendicular to it, I take the opposite reciprocal. So I'm going to flip the negative 2/3 and I'm going to take the opposite, so it's going to be positive. So this slope is going to be positive 3/2. Now for the equation of the line that I want to find, I have a point and I have a slope. So now I can put it in point slope form. This 3, I could say, is x sub 1. This 6 is y sub 1 when I put it in point slope form. So when I do that, I'm going to have y minus 6 equals the slope, which is 3/2, times the quantity of x minus x sub 1, which is 3. Okay, I'm just going to distribute the 3/2, so I get 3/2 x. 3/2 times negative 3 just gets a little messy. You're going to get a fraction. You're going to get negative 9/2. And then the last thing, I'm just going to add 6 to each side. Okay, I'm just going to erase some work out to save some space here. Alright, and then the 6, this is the same as saying 12 over 2. So I'm going to add these together. I just found the common denominator. So when I do that, I'm still going to have the same slope, 3/2 x. And then negative 9 over 2 plus 12 over 2 is 3 over 2. So this is our equation. So 3 over 2 is both the slope and the y-intercept.